Okay, so let's begin. So I actually want to begin from the first homework, which hopefully many of you had a chance to look at, and like even if you haven't, what you'll notice is the basic idea is And by the way, so feel free to stop and interrupt me at any stage, and you can put things in chat. Mohammed will be going through the chat, and Mohammed, if you feel the need to stop me at any point, please stop me, right? Go ahead and just stop me.
Sounds good.
Okay, so what you have is you have a file which has all of Mark Twain's words. Like every single word that he's written of length at least 6 characters. And that's simply so that the file becomes easier and smaller for you to process. So it has all of Mark Twain's words. It's a pretty big file. It's I think it has about 600,000 words. And what you need to do is you need to go through the file. You need to write a program that will answer the following queries. So the queries that are going to be asked are, for any letter, so we'll just think of a letter, say C. What is the kth most frequent word? Right? So your queries are going to be of the form, you get a letter C and you'll get K, which could be, I start counting from 0. So 0 would be the most frequent, 1 would be the second frequent, so on and so forth. And your program needs to process this file and answer these questions. Okay? And so the first issue that you need to sort of grapple with is, how are you going to store all the words? Right? Before even figuring out how you're going to answer the queries, which sort of is part of the process, is you need to think about how are you going to store all these words. So all the words need to be stored, and some of them are going to be repeated. Okay? So what you could do is process the file, and you could say, let's store. Now what I'm going to do is I'm going to give you a specification of how you want to store things. Okay? So given a word, so let's say you're processing these words. Given a word, and let's even ignore the for any letter part for now. Let's just say, given a word, we need to do the following things. We need to find if word is already present, that is already by present is already seen. Then we need to update. Someone said my handwriting is so beautiful. Thank you. Like, you made my day. All this writing, and by the way, fountain pens. That's what makes all the difference. But yes, so you update. So let's say update the frequency of a word or of the word. You insert if the word has not been seen. And maybe, and though you don't have to do it necessarily here, you may want to delete. Remove the word. So this, as we just described here, is a specification of how you want to store the words. It doesn't tell you how to do it, but it's a specification. And such a specification, this is actually referred to as the list ADT, or abstract data type. And for those of you who know object-oriented programming or are familiar, this is like giving you, the interface, or basically a high-level description of the various methods associated with an object which is going to store all the words. Right? So this is the list, and what we're going to talk about is a particular implementation of the list data type using something called a linked list. You can implement this in many different ways. Now, one of the things that we're going to do in the course is we're going to try to implement things basically from scratch, which means you want to minimize the use of libraries. And we're going to try to sort of implement everything from scratch so that you understand how all the higher level constructs in computer science are built. Okay, so this is the list abstract data type. Does this make sense? Do you see why you would need to have some structure of this form for the assignment?
Yeah, that makes sense.
Yeah? Okay, so this is the list abstract data type. Okay, now let's think about what is the simplest implementation of a list. The simplest way you would implement a list. And let's just say for simplicity, let's think of a list of ints, right? List of ints. So in your setting for the Mark Twain assignment, you're going to have a list of words, but it's going to be easier in the lecture to just think of a list of ints. You want to store a list of ints. How would you store them? What's the simplest way to store a list of ints? Any suggestions?
In ascending order.
In ascending order, but how are you going to store them? Store them in what?
Like a
node.
An array.
Array. Right. So someone said an array, which is in some sense the easiest way to think about it. So you could implement the list as an array of ints. Exactly. Okay, so now let's just say you store it as an array of ints. So you could do a find by just a single for loop over the array. Right? That would be a find. So that should be pretty easy, right? So you store it as an array. To insert, you could just insert at the end of the array. Right? If you need to insert a new a number here, you could just go ahead and insert at that point. To delete, now let's just say you have to delete that number. How would you delete that number? What would you do? And so you had to delete that number. There are a bunch of numbers here, and that has 5, a bunch of numbers here. And so if you have to delete 5, how would you delete in an array?
You have to move all the numbers after it forward one.
Exactly. So you have all these numbers, and you could just move it back by 1 and forward, right? You would move it back. You would just overwrite 5.
Someone using subtitles says that the subtitles are blocking the bottom of your paper, so if you can shift your paper up a little bit.
Okay. Is that better?
That works.
I believe that you can individually turn the subtitles on or off.
Yeah, I don't see the subtitles.
I think it's a student that requires subtitles.
Oh, I see. Okay. Yeah, I will. Yeah, I can try to keep it. I can try to leave some space at the bottom. Sure. Let me actually. I think this is fairly close. Let me zoom out a bit. And can you all still read? Is it clear?
Yep, that's still good.
Yep.
Okay.
Yeah, you're good.
All right. Maybe I can move it up a bit more. There you go. Okay, good. All right. So delete. And so delete, you can implement a delete by just sort of shifting entries to the left using a for loop, right? So you could just shift all of these entries down by 1, and that would give you how you would implement the list as an array of ints, right? So you can do find, insert, delete. You can do an update, basically using for loops. So if you think about it, that would be the simplest implementation.
Professor?
Yes?
If we just shift like that in a linked list, wouldn't that cause a memory leak?
This isn't a linked list. It's an array of ints, right? I'm just saying you could implement it as an array of integers.
Okay.
Like that would be the simplest thing. The reason why I want to sort of put this out is you're already thinking linked list, but I want to tell you why should you think linked list? You could just think of an array. So now the question is, for the Mark Twain assignment, why don't you just store everything as an array of words?
It's slow.
It won't be slow. Actually, your linked list will probably be about as slow. If anything, it would be slower.
Because we don't know how many words we have.
Right. So you don't know how many words you have beforehand. And so what are you going to do? How are you going to actually initialize the array?
Could you include an int within the node of the list?
Make a dynamic array?
Or a parallel array to match the numbers and positions of the words?
So when you have this file, you don't know how many words there are.
Every time you go over the size of the array, you have to double its size.
Yeah, so then you would have to do something like some kind of dynamic memory or dynamic array. So let me just I'll just write that down quickly over here. The problem we don't know a priori, which means in the beginning we don't know how long the list will be. And so our problem is, how do we initialize the array size? So as someone said, you could try to double the size. You could make it a dynamic array, etc. And there are various ways of doing this. But the problem is that this is, memory gets wasted. So why does memory get wasted? If you're going to double the size of the array, then you're going to have to allocate that much more memory, right? So how if you've written a piece of code and the code says, I need an array of 100 ints, right? That would be something like, maybe it would see like a is equal to new int 100. Well, then this goes to the operating system, and the operating system is going to look into memory. So here's memory, and it's going to find a contiguous chunk. In this case, your int would be, maybe it's 4 bytes or 8 bytes or whatever, so it's 4 bytes, and so you would need 400 bytes of contiguous memory, right? That's how an array is. So an array of size 100 is a contiguous means it's like sort of continuous in space, continuous in the memory. So you're going to require 400, a big chunk. In this case, okay, 400 bytes is not big, but you need a chunk of 400 bytes of contiguous memory to construct a list. And if you did this, you're not even sure if you're going to use all the memory, right? So it's kind of wasteful because you're going to have to allocate more than you need. Does that make sense?
Couldn't you also determine the number of unique words before you construct this big list?
How would you determine that?
I guess if you go through the file and... Oh, right, I see. Okay.
Right? It's a chicken and egg, right? You still have to store all the words that you see to determine how many unique words there are. So at some point, you're going to have to know how many things there are. Yes? Does that make sense?
Yes.
Any questions?
Yes. Do you think it would be a good use of an array to use it for when we know how many values we have? For instance, if we're organizing everything lexicographically, we could use a 26 size array to store everything from letters A to Z first.
You could store letters A to Z, but you don't know how many words there are with A and with B and so on and so forth.
Yeah, but that could okay.
I mean, sure, you could use an array when you know the size exactly. In this case, you know there are 26 letters. But on the other hand, the problem is you don't know how many words there are of with each individual letter.
Mm-hmm.
Couldn't the array just store pointers to linked lists, though?
That's what I was thinking.
Sure, okay, but then you're using linked lists.
Okay.
What I'm trying to get at is to try to say why you need linked lists over here. You could have just done everything with arrays, and you could actually solve the entire homework using arrays. And the example that I've given is one where it's small enough that you could allocate enough memory. But this is sort of a toy example. Like if you were actually working at a big data company where you need to store maybe billions of records, and if you say, I need to store this in an array and I'm going to be changing the size, maybe I get more, maybe I have to delete some, it becomes extremely memory intensive. So in situations where you need to be careful about memory, arrays aren't the best solution. Arrays are beneficial when you want to do indexing quickly. So there are benefits to arrays.
Don't vectors manage memory really well, though?
Yeah, but as I said, how do you build a vector? The point of this course is to teach you how to write all those libraries.
Professor,
Yeah?
I'm really sorry, but my Zoom crashed. So could you go over that 400 bytes in OS, the operating system? I didn't get that part.
So I was just saying that what happens is when you build an array of size 100, your operating system is going to go and allocate 400 bytes of contiguous memory from here. So it could be the case that even if there are 400 bytes of memory available, if it's not contiguous, you won't be able to construct the array.
Yeah.
Right? So you're demanding a lot from the memory. And so what a linked list is, a linked list is a specific implementation of the list abstract data type. You mean, what I mean by that, it's a specific implementation of storing your data that allows for finds, updates, inserts, and deletes. And I said, and as we just discussed, there are multiple ways of doing it. You can do it purely through arrays. Now, what is the benefit of a linked list? The benefit is it allocates, I'll put this in quotes, exactly the right amount of memory. So we don't need to know the size a priori, and we don't need contiguous memory. These are the benefits of the linked list. Now, in some cases, these can also be drawbacks. Why would it be a drawback? Well, as many of you probably know, for a linked list, you need to store pointers, and those pointers are going to eat up memory, right? So there is that trade-off. Sometimes you want things to be contiguous because then you can index and you can search things more quickly. So there is a trade-off there. But in general, just sort of stepping back and looking at instances where you're not sure about how much memory you need, linked lists are the way to implement the list abstract data type. Okay?
Question?
Yes.
But what did I say? We don't need to know size? A priori?
I'm sorry, it's a priori. A priori basically just means you don't need to know the size beforehand.
Okay.
If you learn nothing else from today's lecture, at least you learned a little bit of Latin, right? A priori means beforehand.
Wait, I thought that just said we don't need to know the size prior.
Prior to building. Beforehand is like prior to building your list, right? Right? Prior to building your list. Okay. Any questions? Okay, good. So now let's continue. And so now let's talk about how you would implement a linked list. So in a linked list, you have a fundamental. So I'm going to sort of, the way that I'm going to write these things is I'm going to write essentially some mix of C style code with some pseudocode, kind of mixed. I've given you implementation of linked list in C++, and I'll talk about this more. There are a couple of memory leaks that I introduced into the code for you to go and fix, just, you know. And the point of my writing over here is not that I'm not going to write precise code, right? And you know, I want you to take these ideas and convert them to code yourself. My aim is to give you the higher level ideas so you can go and write the code yourself. Okay, so I might make syntax errors when I write, and you know, because I'm writing on paper. And again, the point is not that you copy what I write, but rather you take what I write and you are able to code it yourself. Okay, so towards that, let's see, like, how do you store an int in a linked list? So first what we do is we're going to create a class that we call node, and data is going to be stored in nodes. And so you're going to have your data. Now in general, this can be an object. This could be some object in of itself. This is like the data that's being stored. I'm giving you the example of ints. In the Mark Twain assignment, you may have to store something more complicated. You might store a word and a frequency. You could store, you know, whatever makes sense for you over there, or it could even be a pointer to an object. And what's important is sort of this recursive definition, which is there is going to be this is a pointer to the next node. Okay, so this is your fundamental class or structure or whatever. Like, you know, if you're going to do it entirely in C, then you write struct. I'm going to write class. Don't worry about my specific syntax. The important thing is to understand what this object is. And yeah, I see something in the comments. I'm basically writing like pseudocode, C++-ish pseudocode. So the way I'm going to draw my node is it has two parts, right? This part has the data, and this part has the pointer next. And often the way that I'm going to draw this is I'm going to say here's a node. Maybe that node is 42. It has a pointer to another node, and maybe this node has 7. And this is my symbol for null. Okay, so this is the way that I'm going to draw what's going on in a linked list. Okay, so your class, your fundamental object, and this is where you are storing the ints. If you have an array of ints, then you just store it in the individual locations of the array. But in a linked list, you create an object called a node, and in that node, you store the data and a pointer to the next node. Okay? And so let me sort of go on further and say your class linked list So what is your class linked list going to have? Your linked list is going to have a special pointer which is called the head, and this is a pointer to the first node of the list. Okay, this is the first node of the list, and if you just want to look, we'll talk about the constructors of these, subsequently, and you can look at my code specifically to see how the constructors are, and maybe I'll just write this out over here. Yes?
Shouldn't the ending node not be null? Shouldn't it just point to null?
The ending?
Yeah, shouldn't it be a pointer pointing to null, not?
No, it is assigned to null. It is equal to null. So let me maybe just write out what the constructor would be. So let's just say that you have your constructor. You want to insert some value over here, right? So what you would do is in the constructor you would set your data to be val, and you would set next to be null. So that basically creates a node where you have val stored here, and this is null. This is your basic object that you're going to create. Once you create this node, then you are going to sort of link this node to everything else. Okay? And so in your linked list, where you initialize your linked list, your constructor for the linked list, and so let me just get my notes in order. So your constructor for the linked list will often just set head to be null. So this is just saying that when I initialize, I don't have anything. I have a pointer. So my class linked list is just a pointer, and that pointer is initialized to null. Now the important step is doing an insertion. Okay, so now let's see, how do you insert into a linked list? So first let me draw you the picture. So let's just say your current list. So actually let me just pause here and I'll take any questions that you have.
Can you show the other page again?
The previous, this one?
The box right there. Oh.
That.
Right there. Yeah, let me get that real quick.
Yeah. So don't worry, by the way, everything that I write, I'm going to scan and put up as notes as well. So you'll have access to the video. You will also have access to everything that I write.
That is great.
And furthermore, you also have access to my code, which has all of this coded up. Right?
Thank you.
So the important thing is, pay attention and follow, and don't worry, if you didn't take notes or all of this is going to be available. All of this is available.
Question about the node class.
Yes.
Would it be a good idea to have our data our string data one piece of the data and then the frequency another piece?
Yes.
Separate variables.
Yes, so that would be one way of doing it, in which you could actually, your data might, instead of one field here, you could have two fields. One being the string and another being a frequency. Or you could create a separate object that sort of bundles them together and put that here. There are multiple ways of doing it, but yes, you can do that.
Okay, thanks.
Okay. Any questions? Mohammed, if there's something that you think I should answer, please go ahead and let me know.
There are no questions, but there's some questions. One question that was held up from previously, but I'm pretty sure you'll answer this later, which is, in the current assignment, why would we need to delete a word?
In the code assignment, in the current assignment, you do not need to delete the word. You don't need to delete words. For the tests, you're going to need to know how to delete. Right? So your first test is also going to be on linked list, which I'll come to towards maybe the end of the class.
I don't think you have to put void in front of a constructor.
Yeah, so possibly. I mean, that's right. So I can remove that.
A constructor doesn't have a type.
Yeah.
Or at least it doesn't need to.
It doesn't, yeah. So, I mean, and, I don't need to write void. The thing is, my syntax as I write code on paper might have errors. But if there are egregious errors, please let me know. And, this is just a pseudocode, right? I'm not going to feed this into my compiler. I want you to get the basic idea of what's going on here.
That node class,
yes,
where you have next equal to null and data equal to val, would
yes,
that be in our linked list class?
That should be there in the linked list class code that I've provided to you, yes.
Okay.
So all of this, most of what I write is going to be present. Okay, so I'm going to go ahead and...
I have a question.
Yes.
Nodes. Would it be on Canvas or on the website?
I'm sorry, which?
The location of the nodes. Will you post it on Canvas or the website?
On the website.
Thanks.
I'll put it on the website. So on the website, there will be a link to the video and to this. And the reason that I put it on my website is there's one page where you can see a week, day-by-day syllabus or day-by-day sort of setting. Okay, so I want to continue here. And so let's just say your current list is 7. Okay, is 101, 52, and that's null. And what I want to do is I want to insert some value, 42. Okay, I want to insert 42 into this list. So here's the idea, right? So first, so let me just write this out in English and then I'll show you the code. First is create a node with 42. So once you do that, we'll create a node and we have this node that has 42. And note that head is a pointer to that node. Then we link. So what we link is we'll make the new node, and what is that new node? That was this node. Point to the old head node. So we'll make this point to that, and then make head the new node.
Professor, just a semantic question.
Yes.
Is it unconventional to link from the end of the node and insert at the end instead of the top?
I mean, inserting at the beginning is easier. If you want to insert at the end, you have to store a tail pointer. Or you have to actually go through the list to find the end.
Okay.
And then, so what you do is you get rid of head there, and head points to that. Right? This is how you do this. So especially, for those of you who are not familiar with linked lists, I want you to speak up and ask questions, because for those people who are familiar with linked lists, for now, please don't ask me questions about, okay, what if it's a doubly linked list or circular, or if you understand what's going on, then I would like for you to hold your questions and allow people who are maybe unfamiliar with this material to sort of ask questions and clear their doubts. Okay?
Professor, I have a question.
Yes.
So does that mean, just imagining this sort of like conceptually, does that mean that now the head is like at position 0 and 7 is not pushed to position 1?
You can, yes, exactly. You can think of it that way. Although what you want to do is you don't want to. You're absolutely right. It's useful not to think of them in terms of position 0 and 1 because you're not really indexing as an array. But you're right. What happens is everything gets pushed and the head comes in. But what is important here is you don't actually have to push things in memory, which is pretty neat. Does that make sense? You don't actually have to move things the way you would move them in an array. And that's what the linking buys you.
Professor, I have a question.
Yes.
So for
With the linked list, do we ever care about inserting at a certain position in the linked list, or is it always either at the head or the tail of the list?
So in general, okay, so that's a good question. Like, it depends on what you need the linked list to do. Conventionally, this is the way you insert. But if you need to do something fancier, then you may want to insert in other places. If you actually wanted to store things in sorted order, then you may want to insert somewhere else. Conventionally, you insert at the head simply because it's going to be the easiest thing. It's going to be like 4 lines of code.
Do you mind giving an example of like when you would want to insert at a certain position? Because I feel like that kind of defeats the advantage of fast insert with a linked list.
What do you mean a defeat? I mean, it's always okay. So it's always best to write code that is easy and fast. And for inserts this way, it's both easy and it's fast. So it's in some sense the best thing you should do. As for other, we can talk about other examples. And actually during the course, we will talk about other examples where we will insert in different places. But for now, like if this makes sense, I'd like to sort of clarify this to the greatest extent. Does that make sense?
Yes, thank you.
Professor?
Yes.
In regards to linked list versus list, will a linked list take more memory in regards to how much space it takes up compared to a regular list?
What do you mean by a regular list?
Do you mean an array?
Or I mean an array. Yeah.
Well, the problem with an array is you need to know how many elements you're going to insert.
I see.
That is the problem with the array. Like if you knew that I'm going to insert 4 elements only and you have an array of 4, that's better because here you have to store pointers, which takes up more memory. But in many applications, and and especially now we're in the age of big data, and you guys know social media way better than I do. If you imagine Twitter storing all of its tweets, which it does, right? How are they necessarily going to predict how many tweets they're going to get every day? And they're getting billions. And at that point, storing it in an array seems like you have to be really careful.
What about like dynamically memory allocated arrays?
Yeah, but that's a very complicated data structure. Like if you wanted to actually implement that under the hood, you have to do a lot of work. And even then it's wasteful, right? Because when you dynamically resize, you typically take up a little bit more memory than what you need so that you don't have to resize all the time. And then you have to shrink. Suppose you actually delete all of this stuff. You're still holding on to the memory. With a linked list, you can free the memory.
I have a question. When you're continuously adding to like an array list in Java, are all of those indexes still side by side in memory?
Yeah, it's always side by side. If it's an array list, then it's actually all contiguous.
Okay.
The fact that you can index means that it's contiguous.
Okay, thank you.
So I think one of the things that, and I would now encourage you, is actually, that a lot of the a lot of the things that you use when you program are actually incredibly complicated things under the hood. And I want to open up the complexity and show it to you and say, you know what? You don't need all of that complexity for lots of the things that you're doing. And that's why I'm constraining you by saying don't use the libraries. Build it from scratch and see where you can go. And you'll learn a lot in this process. Okay, so let me continue, and I want to write out the code for insert. I want to write out the code for insert, and make sure that you all understand what's going on here. So insert, it's void because it doesn't really it doesn't return anything. So the first thing you do, so I'm just going to sort of go back to my pseudocode. So first thing I need to do is I need to create a node with 42. So let me just, I'll use my constructor to say create a new node with the value. So this is creating the memory, and this is going to create that node over there. Okay? Then I do the linking, and I'll say latest, the next goes to the head, right? And then the head becomes latest, right? So this is linking. And this is resetting the head. And this is creating the memory, or I should say allocating memory for the node. Okay, and then you can just return over here. And you don't need to have the return, but just to sort of put that down, this is the code for a linked list. And so for questions as to, why don't you insert the tail, why don't you insert the position, if all you need to do is insert, then how are you going to beat these, essentially just 3 lines of code with the return? It's simple, it's easy, and it's efficient. Right? And
I have a question.
Yeah.
So when you're creating the new node, why is that a pointer to?
Why is that a pointer?
Yeah.
That's because when you, in C++, when you create an object, you basically, when you use new to get an object, what you get, what that returns is a pointer to that object.
Okay.
Right? So when you use new, you get a pointer to the object. And so the pointer is to the node, and then you do, you go to the next and you reset.
Okay, got it. Thanks.
For the first homework, do you expect us to also clean up the memory we used, or can we just leave it?
Let's talk about, I can answer those questions a little later. First, I want to make sure that everyone understands the insert. But yeah, I will take questions about the homework later on.
Professor, so when you're storing head into latest.next,
yes,
is that the what used to be the old head? Or, so I guess that's kind of where I'm getting confused.
Okay.
Like, it's not overwriting it, obviously, right?
It's not it's not overwriting it. Okay, so shall we go back to this picture here, and maybe it'll make sense.
Sure.
Okay, so actually, you know what? So sorry, I'm going to draw a new picture, and just to sort of give you some clarity here. Okay, I'm going to move this up. Okay, what I want you to think about is really, memory is like this really long array of addresses, right? And so let's look at what we're stored. So let's just say the first node you created was 52, and that's null. Now the next node you created was 101. That could be here, and that is linking to that. Okay? And then, sorry. And then the next node you created was 7. So that is storing that. What does this pointer mean? It's basically storing an address here, and it's storing this address. What does this pointer mean? That means the address of where 452 is being stored here. Now finally we're going to do our last linking step, right? So now we created this thing with, now at this stage, head is storing this address. Okay?
Right.
Now you created your new node with 42, and remember, initially it was null, right? That's just how it's created. But now you need to link this to that. What is the address of where 7 is? That address is stored in head.
Oh, okay.
Right? And so when you do latest arrow next is head, you end up with the address of 7 over here. And so you get that. So this is what has happened after this step. Head is still pointing to 7. So you need to update this by saying, no, head needs to actually point to 42. And that's why head is latest. Does that make sense?
Yeah, that makes a lot of sense. Thank you.
Any other questions? Yeah, go ahead.
Sorry, go ahead.
Both of you. Not simultaneously.
Thank you. I have a question. So, like, why are you creating like a node pointer instead of just a node object?
Why am I creating a node pointer?
Yeah, right there.
So, okay, so what this does, okay, so let's forget this. This creates the object. But what does this return? It doesn't return the object. It returns a pointer to the object. C++, when you, and even in Java, when you create an object, what you get is a reference to the object. And in C++, when you create the object, you get a pointer to the object.
So about that, I was also simultaneously looking at the linked list code that you provided us.
Mm-hmm.
But when you create the linked list, you just created a linked list and then my list. You didn't have a pointer in that.
Without saying, when I said new, you mean?
Yeah, there's no new, but you just created the object.
No, so if I just said, yeah, so there's a difference. Okay, so this is a difference between sort of stack memory and heap memory. Whenever, so let's think of it. When you use new, right, you're allocating this on the heap, and it is going to return a pointer to that. If you simply did this, okay, so actually this is a point worth emphasizing. Suppose I did this. Okay? I did this, and I'll just do latest arrow data equal to value. Actually, this is a good point. Okay, suppose I did this instead of that. Okay? And I should put latest dot next is equal to head. And head would be like ampersand latest. Right? You can change this to sort of set this thing up. Does that make sense? This would be what you're saying. So this is allocated on the stack memory. When this process returns, that memory could get freed.
Oh.
So the node that you created is now going to sort of disappear.
Oh, okay.
You need to use new so that it's allocated on the heap so that when you return, when this process returns, it is still available.
Oh, got it.
Got it?
Now it makes sense. Yes.
Okay. So
I have a quick question
yes.
as to when or if you would ever use like latest dot next you just said versus latest arrow next. What's the difference between those versus like I'm more familiar with Java, and in Java I'm pretty sure you just do dot and then whatever.
Yeah, so the reason with Java, actually, if I may, like a pedagogical point in Java hides pointers from you, and that creates a lot of confusion later on. So this is a good point. When do you use dot? When do you use arrow? You use arrow when you start with the pointer. You use dot when you start with the object. So what's important to note is there is a difference between, okay, so let me, by the way, the best way to learn this is, again, like you'll go and code up linked list and you will burn yourself multiple times, and once you burn yourself enough times, you'll know it. Because I've burned myself enough times as a student, and now I remember it now. So node latest versus node star, I'll call it latest PTR. This creates the object. This only creates a pointer. When you have a pointer, you then need to call new to actually get the object. And then when you get the object, you use arrow from the pointer. But if you actually have the object itself, then you can use dot. The problem with creating an object in this form, as I described here, is it's in stack memory, not heap memory. This creates things in stack memory. This creates things in heap memory. And this is sort of the primary distinction between these things. And in Java, a lot of this is hidden from you. I mean, it's hidden from you for various reasons. And if I may, at this point, just a pedagogical point. One of the issues I see coming up over and over with students is that because software engineering has developed so much, students have access to a lot of advanced software engineering tools, like IDEs, languages like Java, which were built for seasoned software engineers. And the problem is if you learn all of that, you miss out on a lot of the basics that you get by doing things in C and C++ and doing things without an IDE. And I think the right way, the better way to learn is to start from the basics and move your way up sort of to then you go into the complex software engineering, languages and IDs and things like that. So I would recommend, as much as possible, those of you who are doing Java, try to write code in C or C++, and you will start seeing C++ is the best because you have objects as well, and you'll start seeing the distinctions between these things. So hopefully that answers your question.
Yeah, very helpful. Thank you.
Okay, so at this point, are there any questions regarding the insert? Okay, if not, then again, like the code for this is present in the code that I've given you. So play around with it and you can learn from that. Now I want to talk about the next procedure that we need to implement, the next method. And now that's find. So you find some int value. You want to find it in the list. Now I'm going to have it of type node star, not Boolean. And that's because what I want this to do is it should return a pointer to a node, right? There could be many nodes, to a node with val, or it will return null if val is not present. And now I'm going to throw sort of a challenge at you, even for those of you who may know linked lists well, is I want to implement as much as I can through recursion. And I'm going to implement find recursively. And the reason is I want to train you to think recursion. And the recursion is another one of those things that a lot of students struggle with. It is a difficult concept. And so I want you to implement find recursively, and that's what we'll discuss. If you see the codes that I've provided, I have provided both a standard iterative implementation using while loops. There's also a folder called functional. And in that folder, all the codes are recursive. Because I want you to sort of get used to and understand how recursion works. So we are going to implement find recursively. We're going to implement find recursively. Okay? So actually, so let's go ahead and do that. And now one needs to sort of think a little bit. Let's think about what it is recursively. Just think in terms of English. So here's a recursive idea to find. So you say find. Here's how you're going to do. Check if head arrow data is val. And if so, you're done, right? If it is, you just return the head and you're done. And if not, recursively find starting from head arrow next. So what am I saying? I'm saying here's your linked list. Okay. This is head. So you first check, is val in here? If not, you recursively do find starting from here. Okay, that's the logic. So for that, you'll see that whenever you implement a recursive procedure, it's going to be useful to do some amount of overloading. So I think someone commented that recursion is typically slow. That's true. Recursion is slower. But on the other hand, a lot of concepts are more fundamentally explained and understood using recursion. And so it's important that you understand how to implement things both recursively, as well as iteratively. And some of you may know there are actually functional programming languages. There are programming languages that do things entirely through recursion. Okay, so remember, I'm going to define my find procedure here. So I need to find val. Now this is going to be my basic procedure. I'm going to define a recursive one, and then I'll come back to this. I'll come back to this procedure. So let me instead implement another procedure called find, where I have the value, but I also take an argument to a starting node. Okay, to a starting node. And so the first thing is, this is the base case. So if start is null, I return null. This is the base case. If start arrow data is val, then I return start. I return the starting node. I return whatever the starting node is. Or I have to return find val. So what goes here? So what is this?
Start next.
Yeah, start arrow next.
Start arrow next. Start arrow next.
Start a keyword?
I'm sorry?
Is start a key? Oh no, sorry, it's a variable. Okay.
Start is a variable there. Okay, let's just keep and see if I can move that there. I'm going to zoom out just a little bit so that I can show you everything. Okay. So here is my right. Sorry, I think I can't get everything in there. But let's see how. Okay, so what do I do here? What do I do over there?
You can iterate starting at the head and check if a node equals val.
I can iterate, but I don't need to iterate. What I want to do is I want to only do recursion. So this is a recursive procedure to find.
You could pass return find value and then head.
You could just return find the value
and then head,
starting at head.
Yeah.
Okay, does this make sense? So this is, I'm just going to get rid of the old thing so you can put it, you can see everything together. So the old procedure just returns find of the value starting at head, and then this just says that you have a starting pointer. If it's null, you just return null. Otherwise, you check what the value is there, then you can return. So in this case, it's the base case. Here, the value is found, and here is your recursion.
Professor, for the previous find function in the first page, do you still need to check if the list is empty or if the head points to null, or?
Okay, good question. Do you need to check if the list is empty? I claim that you don't need to. See, this is a much cleaner piece of code. Why? You tell me. What is going to happen if the list is empty?
It's going to return null.
Why is it going to return null? Because head is null, so it's going to go into this procedure and start will be null, and it's done. Right? So the base
question: when you implement the header file, how does it know which find method to execute first?
So in the header file, you will give both declarations. This is overloading, right? So what you're doing here is you're overloading.
So like obviously the functional way is for it to call the top find first, and then that function calls the bottom find.
Well, okay, so what you would do is you would write all of this code. But in your code, you would either call this function or this function, and then it knows which one it's doing.
Oh, based on the parameters?
Based on the arguments.
Okay.
Right? So you give it these two, and you'll see in my code I've done this, and this is common in the recursive code, right? That you'll have sort of, this is like a top level, this is like a dummy call. And this is where the real work happens. And typically the dummy call just calls the with start being head.
Professor?
Yes.
In regards to best practices in computer science, since all recursive programs can be written iteratively, when is it better to write something using recursion versus just a normal iterative?
Well, typically, I mean, and this is where, I'm not as much of an expert on this, where, people who do programming languages will say, and this has also been my experience, recursive code is more often than not correct. Like with recursive code, you will run into compile time errors, rarely runtime errors. With iteration, you will always suffer a lot of like off by one errors, or I forgot to check if this was empty. Those sorts of errors are much more common in iterative code. Recursive code tends to be easier to verify, it tends to be cleaner to write, just harder to think about. But it's typically better. Now, on the flip side, recursive code is not as efficient due to things dealing with the stack. The function stack tends to grow up, and therefore, in those cases, typically recursion is not preferred because iteration is faster. But the price that you pay is usually incorrectness. Which is why, and I know this for a fact, and there are lots of companies in Silicon Valley where when they're doing large-scale coding, you actually write everything in functional programming languages. I'll give you a tip. If you want to get ahead in the market, learn functional programming. There are lots of companies that will hire you because you know functional programming, because most people out there don't know functional programming. And often students will come and say, oh, it's not as efficient. I don't need to learn functional programming. I can just do things through loops. But there are companies that will hire you because you know Scala. So learning and understanding recursion is extremely important. Now, when it comes to actually writing code, it depends. Sometimes the recursion can be more expensive and it takes longer to run. But at the level at which our assignments are, it's probably not that, it's not going to be that big a deal. I would highly recommend that you try to write things recursively, or at least know how to write it recursively, especially for linked lists. And you'll see, I'm going to talk about, there are some examples where essentially pretty much recursion is the only way that you can do it with iteration, but pretty much recursion is the most easiest way of doing it. Now you have to, and from pure like aesthetic standpoint, this is a beautiful piece of code. It's really simple, it's really nice, and it's very clear.
I think that's the problem with recursion, though. It's easier to read than iteration, but iteration is more efficient in, I think, at least 99% of all cases.
Well, at this point, I would actually, if I may, usually for students it's a cop-out. Iterative code is easier to write. It's easier to come up with.
Yeah, but if I'm reading someone else's code, especially if they were trying to do some kind of insane optimization or something, the iteration can get kind of funky.
Right. The point is, doing insane optimization is not the best way to understand how to code well. You need to do insane optimizations when you get to that stage. But right now you'll see that, the insane optimizations often will harm you with bugs that are hard to find. With recursive code, the bugs are often easier to catch. So, any other questions about find?
So, is this going to be the ideal way to basically traverse our linked list if we're trying to update the frequency of a given word?
So, again, like as I said, you can see it if it gets, this is the ideal way, yes. But if it seems to get slow, which it might happen in the Mark Twain case because there are so many inserts, then you may want to do it iteratively. Again, like as I said, this trade-off is there. The iteration is faster, the recursion is slower.
Okay, and you have both versions in the linked list example you gave us?
I have both versions of the code.
Okay, thank you.
But I recommend that you understand both. I highly recommend that you understand both. And I also recommend, like, try to write this using iteration, which I'm not going to do. But write it using iteration, and you'll see that the iterative code is also not easy to is fairly easy to write. And I will, at this point, add that now what I would like you to do, just as an exercise, and I also have this written up, is printing the linked list in order. Right? And again, you can do this using recursion, as I did above, or using iteration. Make sure that you're familiar with both of these methods. So is everything clear? Do you understand? Do you think you could, you can write a print code? Well, okay, so you know what? Let me just go ahead and sketch out just writing printing a linked list, but I'll use iteration instead. I'll use iteration. And I'm sort of going to write this with pseudocode. But essentially what you could do is, and this is the most common way in which you would do it, you would have a current pointer which you initialize as head. And then you will say while current is not null, you would print current arrow data. Yes, I know this is not a line of code, but you print it using printf or cout or whatever have you. And then you do current is equal to current arrow next. Right? This is your typical iterative idea, where you have a pointer and you keep advancing it by reassigning it to next. So this is your iterative step here, and this is your recursive step here. Okay? This is the recursive step where you put the base case up here. Right? And the base case condition is here, which is the checking for null. And here that happens in the while condition. So there's clearly a correspondence between the recursive way of doing it and the iterative way of doing it. And as I said, this is faster because there aren't function calls, but this method tends to be, it's in some sense mathematically more appropriate, as well as, it's less likely to have bugs. But again, in cases where you have tons of inserts, or tons of finds, this might not be that fast. It could slow you down. Okay, so this is how I've given you the find using recursion. I've given you the print using iteration. And I want you to be familiar with both ways of doing things. It's very important that you're familiar with both ways of doing things. So at this point, I'm going to pause for a couple of minutes. I'll pause the recording. I will take any questions that you have, and then we'll proceed with the next steps.
Waiting to ask questions that would raise their hand.
Yes.
If you want.
Yeah, go ahead. If you could handle that, that would be best.
Oh, sure. All right, Nathaniel, if you want to go ahead.
I have a few questions. Sorry for the noise in the background.
No.
One is it safe to assume that for the test questions, we'll only be working with singly linked lists, or?
Yes, singly linked lists. I mean, if you read the description, essentially you are going to be working with the linked list implementation that I have provided you.
Right. Okay, and that would solely be singly. Yes. In the homework, it's I'm assuming okay to do doubly linked.
You can do whatever you want.
Great.
By the way, a word for about doubly linked lists. Never code a doubly linked list if you only need a singly linked list. Software engineering advice.
Sure.
Because the more pointers you put, the more scope there are for bugs.
Is doubly just a linked list linked to another one?
It's like it just goes. There are 2 pointers. One goes forward, one goes backwards.
Oh.
So in many ways, it looks like it makes your life easy. You can go backwards, but then if you start inserting and deleting, it becomes messier because there are many more pointers you need to fix. You can do it.
So like there's a back in that too.
There's usually a previous pointer and a next pointer.
Okay.
Yeah.
Okay, the other part was, I think I know the answer to this, but in terms of like swapping nodes around, if I have to reverse something or swap data, do you care whether it's swapping the data fields or
I don't care.
Actually swapping the nodes?
I don't care. Like, again, when I give you the homework questions, I'm like, go ahead and solve it.
Just make it work.
Just make it work with whatever restrictions I provide. Right?
Okay.
And my restrictions are not unreasonable. My restrictions are typically use a particular data structure or build things from scratch.
Totally, and I'm not used to this kind of freedom. Last thing was I already had the counts verified using grep. Wondering if you had any suggestions on verifying rank of a word?
No, I don't.
Okay.
Python, maybe? Write a Python script to also get the solution and then compare?
I was thinking bash, but yeah.
Sure, whatever, yeah. Even easier, yeah. Okay, so Mohammed, can you go over the raised hands and just...
Yeah, I'm doing that as we speak. Richard, can you speak next?
Yeah. Okay, so the first thing I just wanted to be sure of is that, can we assume that we're always going to be building our linked list database of words using twain_clean.txt? Because I know that input.txt is different.
Yes. So you can
output.txt, but
so you want to hard code twain_clean.txt because that's the file that I'm going to be looking at. Like, that's a file that you need to process. So that you can hard code in your file.
Okay, awesome. And I'm not very used to switching between languages for files. I wanted to practice some C++. So is there anything I need to know if I decide to make my data structure in C++ and then decide to make my wrapper in C?
I mean, C is a subset of C++, right? So it's all C++ code.
Right, but can I compile them the same way?
Yeah, you can. They should compile. They'll compile.
Okay.
They should compile. I mean, you just treat everything as C++ code.
Okay, that makes sense. Yeah. Thank you. That's it.
Just a clarifying question. Is the test question going to be some sort of modification of the test practice sets, or is it going to be
modification?
Okay, got it.
So, sorry, can we go by hands, because I think a few people have their hands up for a while. So I just want to make sure that I get everyone who has their hand up.
I was that hand.
Okay, all right, sorry. Okay, good.
It's all going. King. I don't know if I'm saying sorry. You go ahead next.
Thank you. You said it right. So my question is that you said that we do our test questions in Codio as well. I was wondering, do we need to do like the whole makefile and stuff for
No, so during the test, again, if you read the document, I'll explain. So I'm going to give you everything provided, and I'm going to say, write your function here, and I give you the makefile, I give you everything. All you need to do is you type make, I'll tell you what executable you get. Like, everything will be set up for you to just write that function.
That's awesome. Thank you.
Like, I'm not going to make you do all the I/O and all of that in 1 hour. Like, I'm not unreasonable. I'm harsh, but I'm not unreasonably harsh. So, but you know, in the homeworks, of course, you build everything from scratch.
All right, Elias.
Yeah, I had a question. You said that we have to use Vim or VI to code, because do we just have to do that on the test as well?
So again, you don't have to use VI or Vim even in general. I think it's just good practice. In the test also you don't, but you need to code within the box. So what you need to do is you either use a terminal tool like VI. I think I've also installed Emacs, although some people are complaining that the commands are not working. There's Nano, which is even simpler. Or what you can do is if you actually just click on the file in the left pane. In the left pane, you have the entire tree structure. You click on the file, it opens it up as a separate pane where it's a normal WYSIWYG text editor. So you can just type your code in over there.
Okay. And one other question is when I try to implement I try to implement like a rudimentary structure of with your linked lists, counting duplicates, basically counting up the frequencies. But when I try to insert, I basically inserted it at the back, but first I tried to find a node, and then if it wasn't null, if it was null, then I basically increased the frequency. If it was, then I inserted it, but it basically took me over 2 minutes to finish it. The code took about 2 minutes to finish. So or actually more than 2 minutes. So I don't know exactly what.
You might want to insert in the front.
I did. I tried that.
So you're inserting into the front, and something seems off there. It shouldn't. Is it? But it's actually running in 2 minutes. It's terminating.
In more than 2 minutes.
There's probably something, yeah, it shouldn't take that long. I mean, my implementation, again, as I said, takes like 15 seconds or so. What you may want to do first is make sure your code is correct. So what you can do is take a subset of the file, like, take a copy of the file and keep maybe just the top few thousand words. See if it's working correctly. Right?
Okay.
And then see what's going on. The question is, every time you do an update, are you then moving things around every time you update? So just think about that. So if what you do is every time you have a linked list, if you just go through it and you update a word, it shouldn't be too slow. The other thing, and given that we're talking about arrays of linked lists, is are you just storing everything in one big linked list?
No, I tried to split it up. Basically, I have like a letter nodes, a
yeah,
letter linked list, and then word linked list.
If you're splitting it by letter, it shouldn't be that long. I mean, yeah, I'm not sure.
I also didn't. One thing that I didn't know is because I'm not as experienced in C++. Is I didn't use a pointer to a linked list. In the nodes, in the letter nodes, I actually did linked lists. Not a reference. I didn't use a pointer to it, so that might be it.
Yeah, I don't know. That could be, yeah, so you can look into that, yeah.
Okay, thank you.
Dennis, you answer something else?